Let's take some time to work through a practice problem. We are looking at items that are being dropped, so they are moving vertically through the air, affected only by gravity. We are ignoring air resistance for all of our calculations. In real life, many of the circumstances that we will be evaluating would be experiencing air resistance, but it typically would not actually affect the overall outcome of our object's motion. The effects of air resistance would be so small that what we do in this class conceptually is we just leave it out of our calculations altogether because it gives us the same general final outcome when it's all said and done. So with that in mind, this question says that we have a stone that is dropped from the top of a cliff. It is seen to hit the ground below after 3.55 seconds. How high is the cliff that the stone has been dropped from? So the first thing we want to do is identify what our circumstance is, what variables we are given, what information we know should be used in our calculation. As our questions get more complex, as our objects begin to do more things than just simply fall straight down to the ground, you may find that some sort of illustration or visualizing this as a real life incident will be helpful. So for today, I'm going to go ahead and just kind of give us a little cliff over here, and we're going to have our stone, and our stone is going to start someplace above the ground here where that cliff is. And it says that the stone is going to drop, and it's going to fall straight down to the ground. So one thing that I want to make sure that we understand is that we have established that at the absolute highest point that our object will ever be located, we have a velocity of 0. So in this case, because our stone is dropped, that means that it is starting at the highest possible location. So we're going to say that our initial velocity is 0. And then we know that the object is dropping or falling because it is accelerating downward because of gravity. So we are going to use an acceleration rate of negative 9.8 meters per second squared because it is specifically Earth's gravity that is causing it to accelerate, and that is the value that gravity affects all things. So then it says that it hits the ground 3.55 seconds later. So we know that it will be in the air for a time of 3.55 seconds. And so when the story is over with, our object will be right down here on the ground. And so that'll be its final velocity or final location. How high is the cliff that the stone has been dropped from? So they are asking us to identify what this displacement or this height is. And so for this question, we are looking for that vertical position. It's going to be the letter D in our equation, even though the question says how high. But here is our unknown variable. So let's just take a moment to review how are we going to pick our equation. We're going to start by finding all of the formulas that have the letter D for distance or displacement, which in this case is actually worded as our height, but it's the same idea. Remember that we said we will not be using formulas that do not allow for acceleration if our object is indeed accelerating. So we can see right here we do have an acceleration rate because of gravity, and so because of that, we are not going to be allowed to use equation number 1 because it does not allow us to input that acceleration rate. So remember, if your object is accelerating, you must choose a formula that's going to allow us to show that acceleration effect. So that means it's got to be one of these two equations, okay? So now we're simply going to go through the formulas, and we're going to look and see if we have all of the parts that that particular equation is asking for. So I'm going to go ahead and start off with equation number 4. D is our unknown. VI is a needed variable, and it is there. Time is also needed, and it is on our list. Obviously, our acceleration is a known value. And again, remember that T for time is the same time for both places in the formula. So since I have all of the variables that this particular equation is asking for, I can then use that formula. So D equals VIT plus 1/2 AT squared. Please remember that you must write the full formula in order to get credit on free response questions for your quiz and your test. So now I'm simply going to substitute in my numbers. This first value here becomes a whole value of 0. A lot of times students will want to write 0 times t, but remember anything times 0 is just 0. So this number is just going to come out to a big old 0 plus 1/2 of gravity. And remember, it is only the time that is being squared. Now, if you wanted to simplify what you're writing here, you could definitely just choose to only write the second part of this equation. If you're going to do that, though, what I need you to do as well is to take this original formula and show me that you know the full equation, and then somehow illustrate that you understand that this part of the formula simplifies to a 0, and therefore you are kicking it out of your next step. So just make sure that you are clearly showing me that you understand what happened to the VI times T. So then we're going to take this information, we're going to simply copy it or type it into our calculator. And in this case, this is going to give us a negative 61.75225 equals D. Remember, all final answers should be rounded for sig figs. So in this particular problem, they only gave me one measured value. Remember, we have already discussed we will not be using our acceleration due to gravity as a sig fig number because we as a class decided to only write 2 sig figs. It's actually known with more certainty. So we're not using that for our sig figs. We're only using the 3.55 that was actually measured in the problem. So that means that I need 1, 2, 3 sig figs here for my final answer. So we're going to write this as 61.8. Remember, if it's followed by a 5 or greater, you round up. And so we get a D equals negative 61.8 meters as our final answer here. Now, this particular question is asking us how high, but I want to pause and remind you that this is D for displacement as a vector in the formula, the way that it is designed. So you are supposed to calculate a negative 61.8 meters. I would like for you to create a habit of just putting that negative down as your final answer, and then I, as the grader, will go back and reward or remove points if it is not correctly represented as a positive negative, if the question is indeed asking for a vector value. In this case, since it's asking for the scalar version, how high, which would be a vertical measurement from the ground up, I'm actually only going to be evaluating and giving points for this part of your answer. But this way, that negative is there in case it was a displacement question versus the scalar version, okay? So 61.8 meters is how high the cliff is located. Now, what if the question has a second question? What if they are now asking us, what is the velocity of the stone when it reaches the ground? So I'm going to try to save us some time here, and we're just going to say that this is the same story. So we're just going to copy this, and we're going to use that same information. And we're going to continue from here, okay? So it's telling us that we have a stone, and that stone has been dropped off the top of a cliff. It hits the ground 3.55 seconds later. So we're using the same set of givens, but now we're going to address this 2 different ways. For starters, let's just say that this is the question, and instead of asking how high is the cliff, what if the question just asked, what is the velocity? So we were told the stone is dropped 3.55 seconds later, it hits the ground. Just simply, what is the velocity when it reaches the ground? This is not a value of 0. They are asking what is the velocity right here. So whenever we're asking about upon impact, when it reaches the ground, as it lands, I want to know how fast is it moving at that moment just before it touches the ground. So we do want a value here. This does need to be calculated. It is not 0. So using that same list of givens, but now our unknown is the final velocity. Let's come over to our list again and let's just look and see what what formula should we be considering because we are solving for VF. So most students would probably say that these are all of the equations to consider. Right off the bat, let's just go ahead and address we are not going to be using this first formula. Again, how do I know that? Well, we have a couple of reasons here. Number one, the reason that I've already repeated a few times, this does not have a place for me to include my acceleration rate. Number two, I also cannot use this formula because if you notice, this equation is asking, or this question is asking me to solve for the final velocity. And if I look at that formula, it just says V. That V is for a constant velocity, or maybe we'll use that formula for an average velocity, but it is not specifically an initial or a final because that does not account for the fact that we have more than one speed because my object has accelerated. So do not use equation number 1 for this particular question. Remember that these two equations are essentially the same set of variables. So again, I'm going to call this equation 2, 3. Let's look at that and see if that is the equation that we want to use. So we're looking for VF, and we are needing, in order to use this formula, we are going to need an initial velocity, which we do have, an acceleration, which we do have, and a time, which we do have. So because I have all of the parts to that formula, I can indeed use that equation. So I'm starting off with the VF equals VI plus AT instead of using the A equals VF minus VI over T because the algebra is already done for me. So why not make life easier? VF equals, again, this VI is just a value of 0. So you can simply illustrate on your equation that you understand that that's going to simplify to a 0. And therefore, we really only need to write this line when we do our substitution like this. So now we're going to take that 9.8 and we're going to multiply it by 3.55. And that's going to give us 34.79. Now you should be writing this in as a negative 9.8. So you should be calculating a negative 34.79. And then we want to round this final answer for sig figs. So VF equals negative. Once again, we are looking at only 3 sig figs. So we're going to take this 1, 2, 3, and we're going to round that to a negative 34.8 meters per second. Now, this question is indeed asking us for our velocity. So we do have to make sure that we are including this negative in order for us to get full credit for this final answer. So this is why I want you to go ahead and create the habit. If it calculates as a negative, please include that in your answer. If I don't need it, then I will simply ignore it. But if I do need it, then it does make a difference. So if this is a free response question and you fail to put this negative, you do not get full credit because 34.8 meters per second as a velocity means that the object is moving upward, and this is indeed an object moving downward. If this is a multiple choice question and you have a negative and a positive 34.8 as choices, then you need to go back and reread the question. If it says velocity, you must include the right directional final answer, okay? All right, so that's how we would have worked this problem if the question just simply asked for the final velocity. But what if you end up with a question that's basically a two-step problem? So let's look at that. What if the question says, a stone is dropped, it takes this much time, how high is the cliff, and then that's question A. And what if after you've done this calculation, then we ask question B, which says that they now want to know the velocity as it reaches the ground? You can absolutely answer that question doing exactly what I've just illustrated here in the purple pen. I can still go back to that original problem and I can use all of that information VF equals VI plus AT, and I can calculate that answer. The other thing that I could do is I could take the information that I used here with this displacement, and I could go ahead and I could solve for that final velocity using my new displacement information. So we had determined that we had a displacement of 61.75225. So D equals 60 negative, technically, 61.75225 is what we said our vertical displacement was. So what if I'm going to use this set of givens, and now I come over here and I see VF is what I'm solving for, VI is on my list, acceleration is on my list, and displacement is also now provided. So I could use VF squared equals VI squared plus 2AD as another option. If I'm going to do this, if I'm going to use my calculated answer to continue the problem, I do want to use all of the digits that are in my calculator. So if you would please get in the habit of using that answer function as often as possible, or in this case, I wrote down several decimals, so then I could retype all of those decimals into my calculator if this is a question where maybe the answer button isn't going to be the negative 61.7 that I need, okay? So now for my substitution, I'm just going to say VF squared equals, once again, that VI is going to come out to just be nothing. So then I'm going to say 2 times negative 9.8. And then again, I want the unrounded answer. Use that answer button. So now I'm going to say 2 times 9.8 times 61.75, or technically 2 times negative 9.8 times my answer, which is the negative 61.75225. And so now that's going to give me a positive 1210.34, and there's more digits in my calculator, and that is going to equal VF squared. Remember, whatever you're solving for, if it is originally written as a squared value in your original formula, the very last thing that you're going to do is square root. So that's going to cancel out the squared and just make it VF equals. And then again, please use that answer button. And so we are going to get 34.79 as our calculated answer. Now I want to take a second and I want to verify or review a couple of things with you. Number one, we're still going to sig fig this answer, 3 sig figs. So 1, 2, 3 sig figs. So this would come out to 34.8 meters per second. Okay, so there's my sig figs. This is VF, so this is my final velocity. The first thing I want to do is I want to point out to you that we did indeed calculate the same magnitude here. So if I look at my answer, 34.8 meters per second is what we said the speed of my object was. So there we got the same number. Very good. It should work out that way. Like 99% of the time, it'll calculate exactly the same, even if I used either of those equations. But with this particular formula, so this is super important that you guys understand. Whenever we are choosing to use equation number 5, where it's VF squared equals VI squared, if I'm using this equation to solve for either of my velocities, that number mathematically will always come out to be a positive number, because I have to square root a positive number and it's going to give me a positive answer, right? So what you will have to do is go back before you box in this final answer, pause for a second and say, wait a minute, this question asked me for my velocity. My velocity is in the downward direction because velocity is a vector, and you are going to have to go and manually insert that negative so that you can get full credit for this final answer. Remember, you are expected to know if these V's and D's are vectors or if they are scalar values. And then you need to make sure that you are expressing those values properly, okay? So when we look at our two methods for solving this question, I end up with the same negative 34.8 meters per second as my final answer. If I use VF equals VI plus AT, it calculated the negative for me. If I use VF squared equals VI squared plus 2AD, I had to go and add the negative at the end so that I'm correctly showing that directional value for my velocity. But it is important that you understand, what is the question asking for? Is that scalar? Is that vector? And then always evaluate that final answer before you box it in to be graded.